Hello and welcome back. Well, I've gone and done it again. I have volunteered to run another demonstration at our Woodturners Club, and that demonstration is coming up in about a month's time. The demonstration that I'm going to do is on tools, particularly tools that I've made to help me with wood turning. And this is one of the tools that I'm going to be showing in the demonstration. So this is a fluting jig, and this design is based on the Paul Howard fluting jig. Now I do have a video for this build if you're interested in making one of these, and I'll leave the link in the description there. I've used this jig a few times and it's worked pretty good, but there's a couple of things that I need to make for it to improve on the accuracy and to give it some more functionality. One of those things is a fixture that I can put this onto so that it can actually pivot. So at the moment it just sort of slides along at the same level and all your cuts are pretty much straight. But I want to unbolt this and put it on a jig where it's on a bar down the bottom and it will pivot kind of like this. And that allows you to do curved flutes, which you might use on the front of a platter or something like that, or a large bowl. Now that's going to be in a future video, but the second thing I want to make is a good reliable indexing system that I can mount to the lathe and use it for fluting. Now this lathe does actually have an indexing mechanism with this knob at the top here. So if you spin it round, it will just run free, and then if you turn it around half a turn, it'll drop into a pin hole and that will be locked up. Now there's two issues with this type of system. One is that there are only 24 holes for that pin to go into, so that only allows you a handful of options for fluting. And that may be okay for smaller items, but if you're doing a larger bowl or platter, you might want a lot more flutes, and with the system here you wouldn't be able to do that. Now the second problem is that there is a little bit of backlash. You might not be able to see that, but there's a little bit of backlash there. And this is a relatively new lathe, so there's not a lot, but the lathes at the club have a lot of backlash, and that's problematic when you're cutting flutes in your wood here and the chuck is not secure and stable and it's moving around a bit, so your flutes become a little bit curved, I guess, when they're supposed to be nice and flat. So in this video we're going to make up a disc that will go onto the spindle and it will be held on by the chuck, and then we'll work on some sort of bracket that fits onto the lathe bed, and it will come up and engage into the holes into that indexing disc. I need to wait for some plate to turn up for the indexing disc, so I'm going to start on the bracket and the arm that engages with the indexing disc. I have a drawing here, and there's three main parts to this. There's the clamp that fits onto the lathe bed, and that's made of two pieces of bar. And then there's the arm that goes up with a pin in it, and that engages into the disc. And that's bolted onto the clamp connected to the lathe bed. Now for the clamp, I'm going to use this 40mm by 10mm thick steel, and I'm going to slice it down the middle here so it'll be 20mm by 10mm. For the arm, which engages with the disc, I'm going to use a bit of 30mm by 5mm flat bar. Now the third part of this build is a little clamp that fits under the lathe bed, and then there's a bolt or some sort of thing that you can tighten up at the top here, and that holds these rails down tight onto the lathe bed. This is 40mm by 10mm thick flat bar. And I cut a piece off that will do for the rails. I mill down both edges to make them nice and flat. Then I use a face mill to clean up the two larger surfaces. Once the bar is squared up, I mark down the centre and cut it in half with an angle grinder. Those two parts are put in the mill and they're cleaned up on the top surface, and both these parts are now the same thickness. The next step is to make some little spaces that go in between here, and then I'll work on a bolt and clamp system in the middle. Before I make the spaces, I need to drill and tap through here so that I can bolt it all together. This is a M8 thread that I'm tapping right through both pieces. Then I countersink the outside piece and I drill through just the top bar for the clearance for the bolt. Now I start making the spaces. This is 16mm round bar. I drill a pilot hole and then come back and drill a 8mm hole for the bolt to go through. Then I turn off two of those pieces and they fit in between the bar like this. The next step is to make a bolt and clamp that will hold this onto the lathe bed. I'm reusing an old piece of steel that was used for another project. I square it all up in the mill and then I'm drilling a hole down the centre. Now I'm milling down the sides so that it will fit in between the two rails on the lathe. This is the nut which is drilled out and we tap that out to M8. It fits together like this. I'll wind down the bolt and then that can slide freely and then we can lock it up where we need it, and that is pretty solid. The next logical step is to make the arm with the pin that goes into the indexing wheel, and that will slide up and down. But I don't know what height this needs to be, so the next step is to make the indexing ring that fits onto the spindle, and then I'll know what height to make this bar. I'm about to start on the indexing disc, and I've got this 3mm piece of flat steel from a friend. It is 370mm wide, and that's just going to be the limits of putting it on my metal lathe to bore out the centre for the spindle shaft. The plan is to use the angle grinder and just cut around the circumference here, and then weld a boss onto the plate, and then I'll be able to mount that in the chuck of the metal lathe to bore out the centre hole. That centre hole needs to be a specific size to fit over the spindle on the lathe. Now the workable area is this line here. So we have the chuck that covers this area, and then of course the outside of the disc. So all of the holes that are put into this indexing plate need to be within these two lines here. I've looked at a number of indexing discs from our wood turners at the club, and I've made these working sheets in XL. So these have the number of holes for each ring of holes, and then they tell me the degrees for each hole and minutes if necessary. And that way I can dial that into my rotary table. The first step is to cut the disc out with the angle grinder. Because I'm at the size limits for my metal lathe, I need to knock down these high points here. Now I drill a 12mm hole in the centre of the disc. This is so that I can bolt it onto the arbor. Then I start working on the arbor. This is a piece of 50mm round stock. I drill a hole down the centre there, and then that hole is tapped out to M12. And I finish that off in the vise because it's much easier. Now the arbor will need to be also welded to the disc, so I'm just cleaning up that area where it's going to be welded. It goes together like that. Then I put it in the vise and I tack that arbor on. I'm cleaning up the outside of the disc in the lathe. Now this has been sped up. I was running this very, very slowly because of the large diameter. Once the outside's done, that centre bolt is removed, and that will allow me to do the next step, which is to bore out the centre of the disc. I start by using drill bits up to 26mm, that's my largest one. Then I use a boring bar to bore out the remainder. Here I'm checking the finish size, and that looks good. Now I need to remove this arbor or boss. I just cut through these welds, and then I use a bit of hammer on there. I actually did get it off, but it wasn't in camera shot. I clean up those welds with a flat disc on a angle grinder, and then test out the disc on the lathe spindle. Wind the chuck on, and that's good. The next step is to drill out all the holes, and this is the setup that I have. The disc is larger than the rotary table here, so there's no way to clamp it around the outside. The plan here is to use 1, 2, 3 blocks to hold the disc up. The studs here will go through the disc, so I've got to drill 3 holes in the disc. Then I was going to make a bracket that fits on top to lock it all down. But as you'll see, I didn't need to do that in the end. I've already marked out the disc here, and I'm going to go over and drill these holes out. So I'll start with a pilot drill, and then come back with a 12mm drill and drill these holes. It's a little bit fidgety to get in there, but I get in there in the end. I made the centering device. It's just a piece of steel with a 2-degree taper on it, and it centers the disc in line with the spindle. I start marking out the first holes. I'm using a chamfering bit here because the centering drill is not long enough and the chuck gets really close to these mounting bolts. After each ring, I cross out the piece of paper so that I don't accidentally use it again. As mentioned, the chuck would have hit these mounting bolts if I used this centering drill, but now that I've drilled enough rings out from the center, I'm able to put the centering drill in and use that. So it's just like clockwork. Get to the right degrees, drill down, get to the next one, drill down. This is the process at normal speed. If we're doing this marked one here, we've got to look at the degrees and the minutes, and then we turn the table around to the correct degrees. This is on 80 degrees. It looks a bit crooked there with the angle of the camera. Then I've got to bring the minutes round. So when the 1 is in line, that is bang on 80 degrees. Then I need to move this hand wheel around to 39 minutes. And we lock the handles down for the rotary table. Drill the hole. And then go on to the next one. Well, that's at the end of day 1, and I've done quite a few rings of holes here. It's getting a bit dark in the garage, so I'm going to continue on tomorrow. Don't ask me how long this took. Yesterday when I said tomorrow, well, we're actually the day after tomorrow now. But we're getting down to our last hole, and that is it. The disc gets held on by the chuck, and you can see it's not moving here. It's because the disc is binding on the back bearing and the housing of the lathe. I'll take it off and show you. So the inner bearing race here moves with a spindle, but the outer bearing race obviously doesn't. We're putting a disc on here, so it's binding on the outer bearing race and the nose of the lathe here. So we need to make up a little washer to go in here. I bore out a piece of steel to the right dimension to sit on the spindle, and then I part it off. I make 3 washers, 2 1mm washers and 1 1.5mm washer. That's our 1mm washer. And there's 2 of those, and there's our 1.5mm washer. I only need 1 washer, so I've made some spares. Now when we put that on, we can lock it up, and that spins beautifully. The last step is to make the indexing arm. So I'm going to use this piece of steel that's going to hinge at the bottom here. So I need to cut a piece out of the lathe bed fixture here at the bottom, and that's so that I can get a bolt through the bottom of this piece here. And there'll be some kind of way to tighten it, whether it's a lock nut or some sort of hand piece. We'll see how we go with that. At the top of this piece there will be a ball bearing that fits into the holes in the ring, and at the back there will be a clamping bracket that will hold these 2 pieces together tight onto the ring. The first step is to cut that piece off the lathe bed fixture. Off camera I went and tidied these ends up here on the belt grinder. So the next step is to drill a 8mm hole through this one here. This is a 7.5mm drill bit, and then I come back and ream that out to 8mm. Now I start on the indexing arm, and I'm not going to use this 30x5mm piece of steel, because I found this 20x5mm piece of steel, which is better for the job. I cut a piece off to the right length, then I drill a 8mm hole in the end, and that matches the one that I drilled in the lathe bed fixture, because they'll be bolted together there. Now off camera, in that same piece of steel, I drilled a 3/16 hole here at the top for the ball bearing. This is a really good fit, so I'm able to position this in the place that I need it. I just weld in the hole and on the bearing. This bearing is not going to move anywhere, it's just a round locator. I turn this around end for end, and I weld a custom bolt in that 8mm hole I drilled. The indexing arm fits in like this. There's a little washer and then this hand piece. What the f? The bearing gets lined up with a hole, and when you push it on there, it's pretty solid. I need to drill a hole in the indexing arm, and I'm just making sure I'm not going to interfere with the indexing wheel. The clamping bracket will go up the other side of the disc and will hold it all together. Before we do that, I need to mark the indexing arm. This will help the operator know where the ball bearing is from the other side. I drill a 8mm hole in the indexing arm. Now I start working on the clamping bracket, and I use the same material as the indexing arm. This is a matching 8mm hole that I'm drilling in the clamping bracket. Now I've bolted the indexing arm and clamping bracket together, and I'm drilling a 6mm hole through both pieces. The indexing arm is drilled out a little bit bigger, and I tap that hole for M8. That's the hole that I just tapped, and it's plugged with a bolt at the moment while I weld in this custom made bolt. Lastly, I need to make a special bolt for the clamping bracket so it can be tensioned. I'm turning down the end here to 6mm. That suits the hole that I drilled in the clamping bracket. I turn that bolt round and just clean up the end and the outside. I want to make a butterfly bolt here that can be tightened up by hand, so I weld on a bit of plate. This went a bit crooked, so I had to actually cut it off and weld it on again. Once welded, I trimmed that plate down a little bit. Then over on the belt grinder, I shape the ends so it's more like a butterfly bolt. This is how it's all assembled. There's a nylock that goes on here because we don't want this to move once we set it up in the ring of holes that we want. The clamping bracket fits on this side. Again, a nylock nut, but we do not tighten this one up because it needs to move. The clamping bracket is brought up parallel with the indexing arm, and then we screw in our butterfly bolt. As I tighten up the butterfly bolt, the clamping bracket gets pushed out, and that action makes the two top parts of the indexing arm and the clamping bracket pull in onto the disc. And that's nice and solid. I mark out the number of holes for each ring onto the disc, and it does get a little bit tight further on up the top there. I need to get rid of this orange paint, so I'm using a bit of paint stripper. The paint was pretty stuck on, so I had to do this a couple of times to get the paint off. And then I use sandpaper to clean the remaining of the orange paint off. All the parts for the clamping arm are put into a bluing solution, and of course they're put into water to neutralize that reaction. Then they're thoroughly dried off and oiled to maintain protection. Lastly, the disc is undercoated, and then I use a grey as a top coat. It's good to see the numbering is still very readable after it was painted. There you go, that's the indexing system completed and set up on the lathe. And I'll be able to use this in my demonstration, which is actually in 2 weeks now. It was quite a tedious job to drill all those holes, but we got there in the end. Once again, I'd like to thank everyone for watching, and I hope you have a great day.